Hey guys, welcome to the first CodeMonk explainer video. What is CodeMonk? I'll show you. If you head on to our little Hackerearth website right here, just type hackerearth.com, navigate to practice, and then hit CodeMonk. You can see that we offer you a bunch of resources to help you improve your coding skills. You start off with the basics like arrays and strings and sorting. And as you solve these questions, it's completely free. You don't have to pay anything for it. And as you solve the questions, you'll unlock harder concepts, more difficult concepts, and you can move on and solve each and every one of them. Now in Codexplained, I'm also going to be explaining these CodeMonk problems and how to solve them. But let's start off with the basics with the very first problem, Monk and rotation. So the problem is right here, Monk and rotation. Monk loves to perform different operations on arrays. The monk is the principal of the high school and he assigns a task to his new student. She will be provided with an array of size n and an integer k. K denotes the number of steps she has to rotate the array by in the right direction. So what does that mean? If we have a look at the input, this is nothing but the number of test cases. Now in the next line, we've got two numbers, n and k. N, that is 5, is the length of the array which we're going to get. And k is the amount we have to rotate it by. Now this array has to be rotated by 2 steps in the right direction. What does that mean? 1 is currently in the first position. It has to go to the third position. As we can see in our output, 1 is now in the middle. 2 has to go 2 positions to the left, that is to position 4. 3 has to go to position 5. Now when we rotate 4, when we rotate it by 1 step, we go to the end. But when we rotate it by another step, it has to go back to the beginning since it's reached the end of the array. That's why 4 is in the beginning right here and 5 is the second element. Now guys, try to solve it. The coding link is in the description. And the clue I'll give you is that you don't have to use any additional arrays or anything. We can solve it in a time of OFN and a constant space complexity, a space complexity of 1. So take a glance at your screens right here. You can see 1, 2, 3, 4, 5 is our input array. Because we've rotated it 2 times. So what can we see here? We can see that since n is 2, the last 2 elements get displayed first, followed by the first 3 elements. So all we've got to do to solve this question is traverse to the kth element from the end. That is the kth element from the right. In this case, k is 2. So traverse to the second element, the next kl, display all the elements till the end. That is 4 and 5. And once you are done, display the remaining elements from the beginning. That is 1, 2, and 3. What we've got to do is identify this index. Once we are done with that, we can display it very easily. What is this index? We know it's k elements from the end, meaning from the beginning, it will be n minus k elements. So let's try coding it for ourselves. Here we've just taken the input. So if you're using Python, raw input gets 1 line at a time. So first we get the first line and convert it into an integer. That's the number of test cases. So for that number of test cases, we've got to keep repeating this functionality. First, we take the next line, 5 and 2. It will be read as a string, which is why we convert it into int and store that value in nk. Next, we take the next line, and this line converts that entire line into an array, into an integer array, space separated integer array. Now what do we have to do? We have to find that index from which we display the elements. So that index value will be n minus k. However, we can't just write k here. That's because, as we can see, k can be greater than n. So if n is 5 and k is 2, like in this example, there's no problem. But let's say k is also 5. In that case, it's the same as doing 0 rotations, isn't it? Because when we shift 1 to the right 5 times, it will go to 2, 3, 4, 5 and back to 1. So we've effectively made a whole circle. So it's the same as not having rotated it at all. If we make k, let's say 7, 5 will bring it back to the initial position. And then we've simply got to rotate it 2 times. So 7 is the same as 2. So when we have numbers that are really great, we don't need to rotate them k times. We just need to rotate them k% times. That's because we only need the remainder. Now, we've got our index value. So first we display our elements from our index to the final element. So for I in range, it's going to be from index to n. All we do is print those elements. That is going to be ARR of I. And we add a comma at the end so that they're space separated. Next, we have to display the first few elements, the elements from 0 till index. So that's going to be for I in the range index. This is going to ensure it gets displayed from 0 to index -1. Simply print ARR of I, comma. And finally, to separate the test cases, we're going to print a new line. Now let's see if this works. Compile and test. Sample has been passed, and when we hit submit, we can see that every test case has been passed. So guys, that's what I think is a pretty memory efficient way to solve this problem. If you've got a better way or a more interesting way, make sure to comment it down below. I'll be solving each and every one of these CodeMonk problems, so don't worry, they'll all come out in due time. I'll see you guys later.